Right, so for this problem over here, you're looking at a stoichiometry problem that involves limiting reactants. And I already did part A right here because this is something I already created a screencast video for. It's how to find out which reactant is going to be limiting. I have 480 mils of 0.2 molar copper to nitrate, and we have 24.5 grams of zinc. Okay, so these two things are my reactants, and I know that I have that much of my copper nitrate, and I know I have 24.5 grams of my zinc, and you're given that you have 4.89 grams of copper that was formed. So from here, you could also look at this. I have two A's in my problem, and you're trying to figure out what your B is going to be, and my B, I'm going to say, is my copper. Okay, now we're told that when somebody actually did the lab, they got 4.89 grams of copper. Now, what you want to do is you want to figure out, based on what you're starting off with, you want to figure out what the theoretical yield is actually supposed to be. And you figure out here that if you did 480 mils of this and 24.5 grams of zinc, it's always a smaller number that is actually going to form. So theoretically, if everything goes perfectly in the lab, I should get 6.1 grams of copper. Okay. In part B, it's asking for what the percent yield is of copper. This person got 4.89 grams of copper from actually doing the lab. So we know percent yield, it's equal to your actual, like your actual amount that you got, and you divide it by your theoretical, how much you were supposed to get, and then you times it by 100%. Okay, so here the actual percent that I was, or the actual amount I did actually get was 4.89 grams given to you in the problem. And the theoretical, the amount that I was supposed to get from my limiting reactant calculation was 6.1 grams of copper. So I times it by 100, and if you multiply all that out, you would get 80% here as your final answer. Now, the second part of this, I noticed that a lot of you guys had questions on how to calculate what the excess reactant would be. And you're being asked how much of the excess reactant will be in excess. So first of all, if I know that my copper nitrate, this is what was actually limiting the reaction. I didn't have enough of it, so this is what ran out first. Now the zinc, from doing my calculation, I found out if I had 24.5 grams of zinc, I would have had 23.8 grams of copper. So this is my excess reactant. Like I had more than enough of it. And from here, the problem is how much excess do we actually have, right? So you know that zinc is limiting, or I'm sorry, you know that the copper nitrate is limiting, you know that your zinc is what you have too much of. So my question is, how much is going to be left over at the end of this reaction? So it's pretty simple in format. Whenever you have a problem like this, your A is going to become what your limiting reactant was, which was my 480 mils of copper nitrate. And your B is going to become whatever your excess was. And we're going to solve out doing stoichiometry from A to B, just like what we've done before. Okay, so it looks like there's a lag on my computer, so sorry about that for the video quality. But I'm going to begin with my 480 milliliters of copper nitrate. Okay. And because I am beginning with milliliters, you're going to go out of here. We're going to put 1,000 milliliters on the bottom. And on top, we're going to put the molarity of the solution, which was 0.2. And we write it in as moles. Okay. Now you get to the part where it's the multiple switch. And this problem was really nice for us because all the coefficients were just 1. So I have 1 mole of copper nitrate from my equation, and I'm trying to switch this over to my B, and I have 1 mole of zinc. And that, again, we get from the coefficients of our equation. Now, to get to grams, I'm going to put 1 mole of zinc on the bottom, and then on top of this, we're going to put our molar mass of zinc, which we know to be 65.39 grams. Okay, so if you guys multiply all the way through and then you divide by 1,000, and we're going to go to 2 sig figs because of the 480, you would wind up with 6.3 grams of zinc that are used. Okay. The problem didn't ask me how many grams of zinc would be used, though. They wanted to know how much is in excess. So to calculate that, we're just gonna, I ran out of space, but I'm gonna add on to the bottom over here. We began with 24.5 grams of zinc. So I'm gonna take my amount that I actually had in the lab, and then we take out how many grams of zinc were used, the number that we calculated over here. And then you would get to however many grams of zinc we had in excess. And because we're subtracting and we need to go to one place after our decimal, we have 18.2 grams of zinc in excess. And that is all.